channel. The last previous videos we have introduced the graph data structure, and also we have seen some terminologies which is commonly used in graph, and slowly we have moved to graph representation, and now we are in graph traversal. So if you haven't watched those videos, please watch those and come back to this video. So, the traversal is a familiar term from the starting of the data structure. So, traversal in graph here, it's a process of visiting the vertices, okay, in the complete graph. So, now we are going to visit each and every vertices in the graph. That is called a traversal. Okay, so now we are going to traverse the entire graph so that all the vertices have been visited. Okay, so this graph traversal algorithms can be implemented by two techniques. The one is breadth first search, the other one is depth first search. In this video, I'll be covering with an example the technique of implementing the graph traversal algorithm, which is the most familiar one, which is breadth first search. First, let's see the algorithm so that you will come to know like what are the steps involved in working out with the examples. Then slowly, after understanding this, we'll move on to the problem and we'll solve it by using this algorithm. Okay, so this is our the process how we are going to learn the implementation of BFS in Traversal. So first step, we have to consider the graph you want to navigate. So first and foremost, the input of BFS should be a graph, which one we are going to navigate and which one we are going to like use it for our traversing purpose. So second step, we have to select any vertex in your graph. Okay, from the given graph, you have to take any vertex from where you're going to start. It's a source. Okay, so which one is which? Say for example, if you're starting V1 as your vertex, from where you're going to start your traversing the entire graph. That is your second step. So from the given graph, you have to select any vertex. The third step, you have to use two important structure to implement BFS. One is array, the other one is queue. So to implement BFS, we have to have the important data structure, which is nothing but queue. Okay, so here to represent the visitor vertices we use array, and just to just bring that vertices to into the array we use queue. Okay, so always from the graph we go to queue, and from queue we'll go to the visited array. So this is the complete workflow of the BFS. So now we have selected one vertices. Now we are going to start from the vertex, which one you have chosen. You will add that to the visited array. Now once you just started with the vertex, that means your source that is added to the visited array. Okay. Next, and afterwards you will just enqueue there, okay, the chosen or the source vertex adjacent value into the queue. Okay, then we know that queue will work in the concept of or principle of FIFO, which is first in and first out. So next is like you have to dequeue the element from the queue, and then you have to put it or print that value into the output screen. So this is the flow of algorithm to implement a BFS by using queue data structure. So here is an example graph. So first step, consider the graph you want to navigate. So this is my graph which I'm going to do my navigation. Second thing, I need to select any vertex in your graph. So here I'm going to select the vertices 1. Okay, this vertex I'm going to start it. So once I started, what I have to do is, I have a two important structure. One is visited array, the other one is queue data structure. So visited means that all the vertices will be the index of the array. So I have, so here I have mentioned 0 here. So we don't want 0. So 1 is fine. So I'll just erase that because I have only from 1. Okay, I'll just erase it. Okay, so from 1 we have the array. So the vertex. Okay, so here we'll be having so vertices 1 2 3 4 5. So I mentioned in the index over here. So the vertices are the indexes, and here you can see that 0 by default, all the values of the array is filled with 0, because this is the array which where we'll be like involving in visiting. Okay, the visited array or visited vertices will be represented in this array. So by default, all the vertices is 0 because all the vertices are unvisited. So this array represents all the vertices in this graph are unvisited. Okay, we didn't even visit the graph yet. Okay, completely empty. Okay, now your queue is also empty and your array is also empty. So these two empty represents that we haven't visited the graph yet. Now what I have to do is, I just started with this vertex 1. So take this 1. Okay, what is the step here? So you can see this. Starting from the vertex, you have to enqueue. Okay, we have to add that visited array, and then you have to enqueue that into the queue. So first thing is like you have to first from the starting of the array, you have to add that in the visited array. Add that in the visited array means in the 1 I have to change it as 1 because I'm going to visit q now. Okay, visit 1 in the graph. So I'm just changing this 0 to 1. Okay, so I'm changing this 0 to 1. Once this is done, I'm enqueuing that into the queue. Okay, and then what I'm going to do is, I'm going to, after that, using first thing, then you have to do what? You have to enqueue all the v1's adjacent vertex. So then after enqueuing here, what you have to do is, you have to just add all the adjacent vertex of the particular vertex, whatever you have added or whatever you have enqueued in the queue. So here I have added 1. What are the adjacent vertex of 1? I have 2 and 5. So then you make 2 as 1. I'm going to visit now, and 5 as, now you have visited 1, right? So just highlight this color now. Okay, I'm just visited this 1. Okay, now I am just visiting my 2 and 5. Okay, so here I am just changing 2 and 5 because those are the neighboring nodes of 1. So 2 and 5 is added into the queue. Okay, so before that, 1 minute. So before that, you have to remove this. Okay, after visiting, just you have to add this in the visited list. Then you have enqueued 1. Then you are just taking up the neighbor nodes into the visited list. Okay, so then you have to do what? You must remove the element from the queue and then put into the visited array. So now you have to remove the element and just print that value whatever you have removed. I have removed 1 from the queue and I have added. Now I am just add the adjacent vertex of your 1. So my adjacent vertex of 1 is 2 and 5. So now this 2 and 5 is become visited. Okay, now it is visited. Now 2 and 5 is visited. Now what I have to do? I have to take up. Okay, now your front. Okay, starting for the queue, the front is 1. The front pointer is in the 1. Now 1 has been removed. Your front pointer has been moved to f. Okay, this is the front pointer, this is moved to the vertex 2. Okay, so in this 2 you have to take up the adjacent vertex of 2. What is the adjacent vertex of 2? 5 and 3. Okay, so under 5 we have already visited, so now the other one is 3. So make 3 1. Okay, make 3 1 and then add 3 and then remove this 2, add this in the output values, and now you just make your 3 is in visited list. Okay, because you already changed 0 to 1 in under 3. Next is the front pointer is moving to 5 now. Okay, the front pointer, it is moving to 5. Okay, this is removed. Now the front pointer is moved to this vertex. Now what we have to do? We have to take up the adjacent vertex of 5. What is the adjacent vertex of 5? Adjacent vertex of 5 is 1, 2, 3 and 4. So 1 is visited, 2 is also visited, 3 is also visited, only 4 is unvisited. Then go to 4, make it visit and then add that in the queue. Okay, add that in the queue and then you just remove this 5, add that in the output list and then you make this as visited. Okay, now your front pointer is moving to 3. So for this you get the neighbor nodes which is unvisited. So for this neighbor nodes or adjacent nodes are 2, 5 and 4, all the things are visited. So simply remove 3 and add it in the output list. Okay, now the front pointer is moving to 4 and see the adjacent vertex of 4. So adjacent vertex of 4 are, so all the nodes of 4 are visited, all the adjacent vertex of 4 are visited, then simply remove that and add it in the output list. Okay, so the path taken to visit all the nodes or the order taken to visit all the nodes, okay, is defined by BFS over here, or from 1 we are traversing to 2. Okay, so from 1 we are traversing to, from 1 we are traversing to 2 and then from 2 we are traversing to 5 and from 5 we are traversing to 3 and 3 we are traversing to 4. So all the nodes in the graph are visited by using BFS. This is how you have to work. Okay, I'll repeat the same concept again so that we'll have more understanding. Okay, I'll just one more time I'll just explain it. Okay, so here I'll just erase this. So what you have to do is, so once the graph is given to you, once the graph is given to you, you can just just removing the highlighting now. Okay, so that you'll have better understanding. So again I'm repeating the same concept. What you have to do is, you have to create an visited array, okay, of all the vertices in the index position. Just we'll be having 0 here, oh, sorry, no 0 here. We'll start with 1, 1, 2, 3, okay, all the index in the, as the vertex in the index position, 4 and then 5. Okay, so next what we did, next is like simply adding 0 to represent that all the nodes or the vertices are not visited. Okay, to represent that we are adding everything to be 0 and then we have a queue. So a queue is here, actually it is empty. So we know that when it is empty, okay, so we know that we have a front pointer. So this is 1, this is 2, this is 3, this is 4 and this is 5. Your front pointer is over here because it is q is empty, it is pointing to -1. So there is the front pointer. We know that always do q operations will be performed in the front. So this is how you have. Now what we did is, we have actually thing is like we have output, the displaying screen, like the main concept of BFS is like we are going to get the sequence of ordering of visiting the nodes in the graph. That is the main concept. Okay, so what we did is, we just take up any vertices. We are taking the any vertex. Here I am just taking up 1 here. So once I taken 1, what I have to do is, first thing you have to add it to the visited array. So added to the visited array means you are just making this as visited. So now once it is visited, your 1 becomes before you have to replace 0 with 1, which means that your 1 is visited, and then you have to add that into the or enqueue into the queue. Once you enqueue into the queue, your friend pointer is moving to the added value into the queue. Once it is added, then what you have to do, you have to enqueue all the adjacent value of 1. Whatever the thing is added, whatever the adjacent vertex of the queue should be made it visited and has to be enqueued in the queue. Okay, so here the adjacent vertex of 1 is 2 and 5. Make it as visited. To make it visited, I have to change 0 to 1 for 2 and again for 5, 0 to 1. Okay, then I have to add that here. So I'm just adding 2 and I'm adding 5. Once it is added, I'm going to dequeue from the queue. So dequeue is nothing but removing the front element in the queue. So removing front element is nothing but 1 is in the front, so 1 is removed and it is printed on the output screen. Okay, then your front pointer is moving towards to 2. So your front point is updated to the vertex 2, and now you have to get the adjacent vertex of 2. So adjacent vertex of 2 is, we have 5 and 3 and 1. 1 and 5 are visited now. So now we have only thing is 3. So 3 is not visited. So just make it as visited. So change 1, 0 to 1 in 3 and then add 3 in the queue. Okay, then you just change the color of that to yellow. So which means that your things are visited. Okay, these are visited. Okay, so here whatever values in the array is 1 is nothing but it's visited. Okay, once it is visited, what you have to do, so you have to remove that element in the queue. Okay, so just dequeuing the queue, which is nothing but whatever in the front, it is removed and it is added into the output value. Okay, now the front is updated to 5. Okay, so now front is updated to 5. So now we have to take up the adjacent vertex, adjacent unvisited vertex of 5. So the 5 unvisited adjacent vertex is 4. So go to 4, change to 1 and make it as visited. So once it is visited, and then just color change it here. So now you have been make it as visited and you have to add that into queue. Now the queue is added with 4. And then now you have to remove this. Once your adjacent vertex is added, you have to remove this element and add into the output list. Now the 5 is added here in the output list, and then front is updated to 3. Now check for the unvisited adjacent vertex of 3. So the adjacent vertex of 3 is 2, 5 and 4. These 3 are visited. So simply dequeue from the queue and add in the output list. And again just go to the front and update the front to 4. Okay, now all the elements in the queue is removed, only 4 is left. And what are the adjacent vertex of 4? Is there any other unvisited adjacent vertex? For adjacent vertex of 4 is 3 to 5, everything are visited. So simply remove that element and add it in the output list. So make your queue empty. Okay, all the elements in the queue are removed and all the visited, okay, elements are become 1 from 0 to 1. When once your all the vertices becomes 1, which means that all the vertices has been visited. Okay, now the order of visiting the nodes in the graph is given by this particular values. So here now the order is how to how the graph has been traversed by using BFS. So from 1 it is traversing to 2, and from 2 it is traversing to 5, and from 5 it is traversing to 3, and 3 to 4. You see here all the nodes or all the vertices has been visited. Okay, this is how you use BFS to implement the graph traversal algorithm. So to visit all the nodes. Okay, so if you have any doubt, please ping me in comments. Thank you. Happy learning.